So the next topic that's going to be on the exam are confidence intervals. So confidence intervals, we have 3 different ones that we might do in the class. If it's for proportions, we're doing this, yeah, you got the whole table. And then we've got the sort of breakdown of what it is we need to be able to do with confidence intervals. Now we know these 2 things are going to happen. Again, you're going to have a part A and a part B. Part A, calculate an interval. Part B, interpret the interval. Other things that you're probably going to see are the things below. These 4 will probably be done as multiple choice, right? So finding our critical value, we saw this in the Kahoot as well as in the actual knowledge check, right? Figuring out how to find a Z star or a T star. More likely on this, it'll be the T star because that one has a little bit more going on with it. Determining how, if we change a sample size or a confidence interval, how that will affect our interval. And we know that if we decrease the sample size, we'll have a narrower interval. That's a lie. Don't believe me. If we increase our sample size, we'll have a narrower interval. We'll have more precision. And if we decrease our confidence level, it's a trade-off. We'll have more precision, but we'll be less confident about that interval. So those are the 2 ways that you can make your confidence interval narrower. Confidence intervals, the other thing that can make them narrower, if you have the actual population standard deviation, this would also result in a narrower interval. But again, this is really silly. It's never going to happen in real life that you have the population standard deviation. So it's just wishful thinking that you might be able to do that. And then, of course, you have the assumptions necessary, the same ones we've been talking about again and again in part 6 and 7, independence, SRS, and less than 10% of the population, and our rule of thumb, having a large enough sample size to get normality. And then the last one here, finding a point estimate and a margin of error from the given confidence interval. And this one, just remember your point estimate, you're going to add the lower and upper together, margin of error, you're going to subtract them. And this was all about the fact that when you make a confidence interval, you start with your estimate, right? And then you add a margin of error and you subtract a margin of error. So if you want to figure out your point estimate, right, you just need to figure out where the middle of your interval was. So you average. And if you want to find your margin of error, well, you went out a margin of error to either side. So you have 2 margins of error in the range of your data. So if you just subtract and divide by 2, you'll figure out what half of your range of your data is. So we can, of course, look at some examples here. You have some resources where you might find videos, what worksheets might be useful here. But this is exactly what the question will look like on a test. You read through your question, but before you even read through it, I look down here and say, aha, calculate an interval, interpret an interval. I already know what I'm doing. I already know what my interpretation is because I've got that on my note card, and it's just a matter of breaking down the different pieces. So a survey was conducted to determine the average loss in home value in a certain community. So I could sit here and look at the underlying variable. X is our loss in the home value, which is quantitative. But they also gave me a huge keyword here with average, that we're doing a confidence interval for means. So right off the bat, thinking back to my formula sheet that's going to be there to help me on the exam, I can sit here and go, okay, I'm doing a confidence interval and it's for means. So I know I'm here or here. And as soon as I make that decision, I realize it's going to be very important that I read carefully to determine whether I have a sigma or an S later in the question stem. So we continue back to the question. A random sample of 23, all right, so we got the word sample and we've got our sample size. Homes found a mean. This mean is in the same sentence as sample, so this is an X bar. With a standard deviation, again, same sentence. We haven't changed sentences. This is still the information from the sample. So that's an S. Assume the unnecessary assumptions are met. So ignore any weirdness. Theoretically, in order to get out a t-distribution, we need to have an n of 40 or know something about the underlying distribution. So this is why they're just saying, let's pretend it's good and let's go. So immediately, as soon as I see this S, I know I'm doing a t-interval. If I'm using the formula sheet, I'm grabbing that second formula there for means. If I'm doing the calculator, I'm just typing in t-interval right now. So So I'm going to do this by hand just for the people who don't have a little calculator. For those of you with the big calculator, feel free to fast forward. So little calculator, we have our x bar. We do need to go find t star, and our t star we know means we need a degree of freedom, which is 23 minus 1 or 22, and we're going to use that 99% confidence interval. So we're going to that sweet t table. We want 22 for our degree of freedom. I've already forgotten what our confidence interval was. 99%. Oops. And we're just figuring out where those two things intersect. All right, so 2.819. 2.819. And then we're just continuing plugging in. S we found was 1600. N was 23. I like to do this with doing the margin of error first. So if I was doing this with a little calculator, I would calculate 2.819 times 1600. Oops, that's not 1600. Divided by the square root of 23. And then I would redo this. 13120 plus or minus. That is not what you need to see. 940 4834. 940 4834. And then I would add and subtract, right? Because I do need to give this thing out as an interval. Now, another thing to note here. So can't talk and type. It is a failing of mine. Even though this is a really boring part for you guys to watch, I know. Alright, so it looks like I have 2179.52 and 1406048. Alright. So here's the one piece that's important. At some point you need units. You can either put units on this, throw a $sign out in front, or throw dollars on the back end. Either way is cool. Or you can do it in your interpretation. But if you don't write your interpretation, if you use the kind of lazy one that I had in the notes of is within the interval, if you don't have units up here, you're going to get docked points. So just make sure that you either put units here or in your sentence. So for your interpretation, we are 99% confident that and this is where you want to go back to your original sentence, population mean loss in home value and if you're grabbing that sentence from part 6, just remember this used to be proportion and now it's mean or average when we're in part 7, so that piece will change. And then is between 12179.52 and 14060.48. So if I put dollars here, I put my units up here, I will be fine if you don't have units on the interval itself. But if you're lazy and just say is within the interval, you better have units on your interval for full points. You can see some additional questions. These are all nice multiple choice. So the next one here, we could read through. We got a random sample of 228. They gave us an N. 27 reported having their tax returns audited. So it looks like this is our X, our number of successes. And the variable that we're looking at underlying is whether or not a tax return was audited by the IRS. And then they ask us which of the following is a 90% confidence interval for the proportion of people audited by the IRS. So this is one where if you're doing this by hand, you're going to your formula sheet again. You know it's for a proportion. You know you're doing a confidence interval, so you're using this formula. Oops, there was a big S, square root instead of that. Square root, B hat, Q hat, all over N. And this time I'm going to do this with my big calculator. I know if I'm doing, this with my big calculator, I'm doing a 1 proportion Z interval. And I'm just going to tell it what my n and x were and what confidence level I wanted. So it looks like we should have 0.0832 to 0.1. Perfect. Part C. Or answer C. If we calculated a 99% interval instead, so if we increase our confidence level, what will happen to our interval? So this is one where you have the ability to just plug this back in your calculator as 99% and see what happens. Or we could use our common sense here. The confidence level impacts our z star. It impacts the margin of error. It does not impact our point estimate. So our midpoint should stay the same, right? Our estimate is still our estimate regardless. So we need to get rid of everything that says our midpoint will change. So both B, C, and D are all out. And now the question is, would the width increase or decrease? And if we increase our confidence level, we could look at our table just to verify. But as you increase your confidence level, look what happens to those Z stars. They get bigger and bigger. So if that's the case, and we're going to multiply by that Z star, if we increase our confidence level, this will go up and the whole margin of error will go up, resulting in a wider interval. Boom. E. You can see the rest of these, right? So these are another ones. If I were you, I would take a moment to try these all on your own, and then check them with the little piece of paper. If you want to have me walk you through them, I will do that now. So we can see this one here. We've got a simple random sample of size 21. They just gave us an n. Taken from a normal distribution with an unknown mean and standard deviation. It was used to calculate a 98% confidence interval for the mean. Okay, so we already know in terms of formulas, in terms of what we're doing, this would be one of these formulas, right? Because we do not know the standard deviation, and we're making it for the mean. So this is our formula. What table value or critical value would you use? So the critical value is all about that T star. That's what we get out of the table. This is where we need to think about what our degree of freedom is and what our confidence level is. And we need to figure out where those two things intersect on our table. So 20 and 98. So coming here, 20, 98, 2.58, 2.528, my goodness, 2.528. If you actually look around at all these other wrong answers, most of them are just being off a row or a column. So be very careful. Draw on the sheet that I give you. You don't need to keep it, so you can draw all over it. And then A is getting a Z star instead of a T star. 6 says that we're going to estimate the true proportion. So immediately we're thinking confidence interval for a proportion. About Chuck Norris's roundhouse kicks that hit their intended target. A 95% confidence interval, so now they kind of checked that box of yes, we're doing an interval, was calculated, and it's that. What is the margin of error? So remember here, if you think about the way our interval was made, I'm going to be lazy and round this. We started with something in the middle. In this case, something right around 0.8, right? We went up and down. And the question is, how far do we go up? How far do we go down? Because that's our margin of error. The quickest way to do this is to just calculate the range. How much difference was there? And then divide it by 2, because we have 2 margins of error, one on the front, one on the back. And that's how we can do our calculation. Most common mistake on these questions on the exam, 2 mistakes, and they're both calculation based, so definitely write down what you're doing, because if you have a calculator error, I'm just taking off 1 point. But if you don't write down what you did, I have to take off all 4. 0.8, this is the most common mistake. And I saw a ton of this on that last worksheet that I graded. As doing this, where only the last number is being divided by 2. Do not do this. Instead, either do it in 2 steps. So that's another common mistake, is forgetting to do the dividing by 2. So don't forget that. Our margin of error here should be 0.0212. All right, and then the question we all know is coming, narrower confidence interval, how do we do that? We know if we have a larger sample size, we will have a narrower interval. If we decrease our confidence level, we will have a narrower interval. and a Z interval technically is smaller than a T interval. And that you can see by just looking at all these Z's. They are smaller than the T's above them. So those are our 3 ways to get a narrower interval. Again, I'll make another video for sample size, but I'm telling you, you can just go through these on your own. But they will be here. I'm wasting like hours of my Saturday making these.